Hi, I'm Alan Kramer, Senior Strategic Applications Engineer at Stratasys. I'm going to show you the benefits of using FDM 3D printing technology to make surrogate parts and what's involved in designing and printing them. Mass production startup or a model change of any new product involves many critical phases. A common issue in the early phases of production startup is the availability of parts. Without physical parts, the level of readiness and setup accuracy is limited. Traditional workflow means waiting to begin a pilot build until physical parts are available. Setup on equipment is done prior to this phase using only measurements and simulation. But the process of handling, machining, inspecting, and assembling these components always exposes some discrepancies between simulation and reality. FDM 3D printed surrogate parts can serve as physical parts in this setup and trial process, minimizing the time and cost impact of waiting until actual production parts are available. When printing surrogate parts, there's no need for premium materials or fine surface finish. Another unique benefit of FDM is the ability to control the infill of the part. This reduces print time and material consumption, lowering the overall part cost. Users have infinitely variable fill and outer shell options available in our software. These parts can be utilized in training and setting up of robots, vision systems, CNC work holding, and even training assembly line workers. This part represents a cast aluminum housing for a hydraulic pump. It was printed in ASA material in this bright yellow color so that it stands out. Parts can easily be painted with a metallic finish to more closely represent the final part when training vision systems. When this part is handled during the training process, it is important for the part to have the same mass as the final production part. Since the production material properties can be applied to the file, this data is available to you in your CAD software program. On this part, I left an opening on this bottom surface which allows it to be filled with a low-cost, fast-setting mix of epoxy and steel BBs. By simply placing the part on a scale and adding this weighted mixture inside the part and applying a cap to the opening, it will then have the same mass as the production part. Now when any machine or person handles this part during a training or setup exercise, they will be working with the actual physical shape and actual weight of the final production part. This is a level of detail that offline programming and simulation cannot offer. Robotic arms must be programmed taking into account the deflection and positional offsets of rapidly handling a part of the correct mass. You and your team will also benefit from handling a mass-accurate physical model to determine if a lift assist device may be needed to prevent worker injuries. This application can be taken a step further by creating several versions of the part. In this casting example, CAD files already exist of the die-cast model and the final machined model. Each of these could be used in different areas, serving as highly valuable training tools. The machining operators need to prove out their work holding, robotic cells, in-feed, out-feed conveyors, and other pieces of equipment that will interact with the final part. Your assembly line team will benefit from a different version of the part, with all surfaces and holes machined and ready for hardware and other components to be added at each workstation. You can also print non-functional surrogate models of specialty cutting tools. These parts are used to confirm tool changes and programming. The quality control department also needs to set up and confirm the work holding and programming of their CMM machines. They can do all of this many weeks prior to having the first production part available. Surrogate parts carry relatively low material requirements that can often be satisfied with low-cost FDM materials traditionally used for prototyping. By using 3D printed surrogate parts, day one of your mass production startup will go smoother. Imagine a plant where every machine and worker has seen, handled, and assembled the new model as a surrogate part during many training exercises. To learn more about this and other applications, contact your Stratasys representative or visit stratasys.com. Thanks for watching.